Basically, you want to sketch this polynomial using end behavior and root behavior, right? So what we're going to do is we're going to first find the degree of the polynomial, okay? So I'm looking at this polynomial and I need to know its total power, the degree. Is it an odd function or is it an even function? When it's in its factored form, you add together all of the powers. So basically, if we multiply, we FOILed this all out and got it back into standard form, what would be the highest power? And when you FOIL all this out, you'd FOIL x squared times, and then this would FOIL out and have an x squared term, and this would FOIL out and just have an x term. So the total degree is 5, right? And then you have your leading coefficient. Now, you look at the coefficients in front of these x's. So basically, if I multiply these out, this would be 1x, this would be times 1x squared times 1x squared, and my leading coefficient is 1. Okay? So since my polynomial is degree 5, it means it's an odd function, which means one of the sides are going up and one of the sides are going down. And because my lead coefficient is positive, it's positive 1, basically this looks like the cubic equation, and it goes up on this side and down on this side. Okay? So I get this end behavior from the total power of my polynomial, my degree, and my leading coefficient. You with me so far? Okay. Now, to do the rest of the sketch, we know what's happening on the left and right. We need to find out what's going on here in the middle. Okay, and by doing that, we look at the roots. So this has 3 factors. These factors are what give us our roots or x-intercepts. So technically, you're supposed to sit here and set each one of these equal to 0 and solve. But what makes x squared 0? That's when x equals 0. What makes this root 0? When I plug in x equals negative 2. What makes this one 0? When I plug in positive 3. So these are my roots. Okay? And this root has multiplicity of 2. This root has multiplicity of 2, and this root has multiplicity 1. Okay? Which this root multiplicity is telling me what happens at this x-intercept. So since this one's even, this one bounces. So this one bounces, this root is even, it bounces, and this one's odd, so it crosses, and since it's power 1, it crosses linearly. Okay? You with me so far? So again, just like when we did degree, we were looking, is this number odd or even? If it's odd, it is like the cubic. If it's even, it would look like a quadratic. Same thing here. We look at the root and we look at the power. If it's even, it bounces. If it's odd, it crosses. So basically, we're just looking at even and odds. Okay? So now I'm going to graph my x-intercepts. I have this one at 0. I have one at negative 2 and one at positive 3. So those are my zeros. Okay? We good? All right, so the last part. Now we're going to put all of this information together. Okay? So I always tell my students to start on the left. So basically, an x-intercept is where my function crosses or touches the x-axis. Since I know this end behavior on this side is going down, whatever happens anywhere else, I know that when it leaves this root, it has to go down. It has to look like this because it has to match this arrow. And since there's no other x-intercept, there's no way it can come up here and cross again, so I know it has to come down here. Does that make sense? Okay. Now, this root at negative 2, right here, what does it do at the root? Well, it bounces. So when it comes up here and hits, it's going to bounce. So it's going to look like that. And then it's going to do something. It's going to go down. I don't know how far it's going to go down. It's going to go down pretty far. Well, I guess technically, if you plugged in 1 in here, you'd get 1, and that would be 3 squared, which is 9, times -2 would be like -18. So it would be way off the graph. But I know it's going to come down here, and it's going to come back to this root. So it's going to go down, and it's going to turn around, and it's going to come back here. Okay? Now this root at 0, what's the root? Well, it has multiplicity 2. So what happens at this root? It bounces. So it's going to come up here, and it's going to bounce off again. Then it's going to go down, and then it's going to come up, and it's going to come up, and it hits this root. And this is your x equals 3 root. It has multiplicity as 1. So what is going to happen at that root? It's going to cross. It just comes up and it crosses. And look, my end arrow matches the behavior that we said at the very beginning. If it didn't, if this didn't match this at the end, then that would be telling me that I possibly had made a mistake and that I should go back and look at my roots. And the other thing I need to make sure is I didn't cross or touch the x-axis anywhere I wasn't supposed to. The only place that I drew should hit the x-axis is here, here, and here. And if it hits anywhere else, then there's also something wrong. So you can check yourself that way.